Hey guys, what's up? Welcome back to the classroom. It's Mr. Low. And today we're going to discuss on the next chapter, which is chapter 14 on statistical data handling. Right. So I think this chapter is very practical. It's very useful for our daily lives. Especially if you go into companies that when you're doing sales and you need to present your data to your bosses, right? For example, I want to sell this product, right? And I need to convince my bosses that customers actually do want it, right? So how are you going to present your data, right, to convince people that your product, people actually kind of want to buy it, so that people can start producing and selling your product, right? So let's take a simple example, right? So here your class wants to sell ice cream cones of ice creams, right, for charity events in school. And you before you actually sell, you actually done a survey to ask around like what kind of flavors they actually like, so that you can, for example, buy more, stock up more of the flavor that your schoolmates prefer, right? So you are able to get five different types of flavors, right? So these are the five flavors. Okay, and after some survey, after surveying 100 students, this is the data that you got. So my question is, how do you present it in a picture, right, or a graph, whatever, that is easy for people to understand? One look, they can tell, oh, which flavor is more favored, and by how much is it the favorite of the students. So there are many ways to go about presenting this. So here there are a few ways, that I can think of, right? Okay, so this is what we call the bar chart. This is the pie chart. I forgot what this is called, but some of you might have seen this before. This is the line graph, and this is the pictogram over here. Right? Of course, there are many other creative ways to present data out there. You can go and Google, right? But the next question that we should ask ourselves then is: all these methods suitable? Or which one is the best uh, way to represent, right? So we're going to study a few ways of representing this data in terms of pictures or graphs, right? And we can figure out on our own, right? It depends on what is the situation, depends on what kind of data that we have. There must be there's a best way to go about presenting them, right? So let's look at some real life examples, right? So this is obtained from Chinese News Asia website, okay, in early March, right? Updated 2nd March here. This is on the number of cases of COVID-19 in Singapore, new cases confirmed, and you can see here, here they are using a bar graph, right? So the x-axis over here is the date, ranging from late January to the whole of February, right? So you can see very clearly, when at which dates, right, that you have higher numbers, right? From here, one look is very clear, right? And then when they present the total number of cases here, they use a line graph, right? So you can see that, yeah, over time, the number of cases has been steadily increasing. Okay, but how fast is it increasing? That's something you can ask yourself, right? So if you've learned the concept of gradient, then or if even if you don't have the idea of gradient, you can sort of figure out, right? The steeper the graph is, it kind of represents a sharp increase, right? A faster increase in a shorter period of time. So one look you can tell, right? How what's a general trend? Well, it's increasing, right? And when is it that there's more increase, a faster increase? Maybe somewhere in this period. And so this kind of representation is very useful and very clear for readers, right? I don't have to look through so many numbers, so many data points. One look, this graph, I can tell what on earth is happening. All right, so in this chapter, we are going to study a couple of types. We're going to learn how to, I'll not say draw, but how to read. How do you read this kind of graphs? Okay, how to get information out of them. Right, so the first that we're going to learn is what we call a frequency table, right? So it goes like this, okay? So the following, this is a student of 40 students, right? And these are the grades that they obtained. So you see there are, for instance, there's A, right? That's the best score you want to get. There is like D, E, sorry, all the way down to E. Okay, so you can present them in a frequency table first. We're not even talking about graph first. Okay, we're presenting them in a frequency table. First of all, you see this word frequency. Okay, what does this mean? Frequency means number of times it appears. Sorry, number of times a particular item or data appears. Okay, so you might want to take this down in your notes. Okay, number of times something appears, right? So grade A. So let's take a look. You have a grade and you have A to E. Okay, this tally thing, I'll show you what is it. And at the end, frequency is just a number, how many times it appears. So let's take a look. How do we use this table? I'm going to zoom out a bit. Okay. Okay, let's look at A. The first item here, grade A. So the tally works like this. Each time I see a letter A, like for example here, in this case, I'm going to make a stroke. Okay, so let's do this together slowly. You can do together with me on your notes. Okay, so A one time. So this second time I'm going to make another one. Third time, 3. Anymore? Yeah, here 4. Next, I see another A over here. Right, 5. Now, when it comes to 5, I do not draw a vertical line. Instead, I bundle them up, in fives. So this is what we mean by tally. So it's very clear, you know, when someone sees a bundle like this, a horizontal line with 4 strokes, immediately they can see one bundle is 5 counts. So based on the number of bundles, you can estimate, right, roughly how many times this grid A appears. So I'm going to write on the right hand side here, frequency is 5. So you can do this for B. Let's do it together. 1 time, 2 times, 3 times, 4, 5, 6, 7, 8. I hope I'm not missing anyone out. Okay, so there are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Right, so 5 plus 3, so 8. All right. C, I'm just going to change another color. 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10, 11, 12. Right, so 12 of them. Okay. Yep, so I'm going to draw in bundle of 5. 1, 2, 3, 4, 5. So 2 of 5 makes 10. Then I have another 2. So that's 12. Okay, D. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Yep. Okay, I'm not missing anyone out. So one bundle of 5 and another 4. So that's 9. Okay. So the remaining E is easier. Okay, 1, 2, 3, 4, 5, 6. Right, so 6. One bundle of 5 and one extra 6. Right. So in this case, I think I did something not very good here. I actually circle. Circle makes things very complicated. What I recommend is you can cancel. Cancel, cancel, cancel. Just like how you do close passage in English. When you use the word, you're done with using the word, you strike it off so that you don't repeat. Right. So I see that I've circled everything here. I should have everything inside. Now how do I know that I've counted everything correctly? Let you guess. Well, the frequency tells you everything, isn't it? Right. So here we have the total. And let's count. 5 plus 8, 13 plus 12, 25. 25 plus 9, 34 plus 6 is 40. For 40. How do I know that I got correct? Well, you can check it over here. There are a total of 40 students. Alright, so it's quite easy over here. Okay. Yeah, so tally is bundles of 5, and then the frequency, right? For those Chinese students, okay, I don't know if you watch some shows, right, some ancient drama or whatever, there is another way of telling, for Chinese. So instead of bundles of 5, they write this character. It's also in 5 strokes here, right? So 1, 2, 3, 4, 5, 5 strokes. Okay, this is a Chinese character, right? For those who are not too sure, you can ask your friends what this word over here means, right? But we're gonna use this kind of bundles over here, right? So after we're done with the frequency table, usually um, there are more questions to answer based on the frequency table. So what grade was obtained by most of the students? What grade was obtained by most of the students? So let's read this carefully. Okay, by most of students, what does this mean? What is this question asking? Well, it's asking which grade does most students get, right? Right, in this case, you can either look at the tally or look at the frequency. We know that, okay, for grade C, there are more people. Most students got grade C, right? So you just write down grade C. We'll stop, right? Quite simple. Now, you do not write the frequency. That means you shouldn't be writing the number 12. You should be writing the letter C because they're asking for the grade. Okay. Next, find the percentage of students who got obtained grade A or grade B. So percentage of students. So this one is quite clear. So we want to find how many students got grade A and how many students got grade B. You add them all together and you find the percentage out of all the students, right? So let's go back to our frequency table. Okay, grade A, there are 5 of them, and grade B, there are 8 of them, right? Total 40 students. Okay, so we can immediately write it down. Percentage equals to number of grade A's plus number of grade B's over total multiplied by 100%. Right, so that's 13 over 40 times 100. Okay, I forgot to pull out my calculator. Please give me a moment. Okay, so 13 divided by 40 times 100%. So that gets me 32.5%. Alright, so yeah, I'm just gonna write it down. 32.5%. So remember that yeah, this is an intrinsic fix, so it's fine. Alright, so moving on. Okay, so this is an example. The next example I will not discuss. You will try yourself. Okay, if you have questions, then we will discuss in class when we meet. Right, but this one is a bit more interesting. Okay, let me just go through the question with you first. There are 30 students. Okay, and the data shows the time taken for them to solve the same problem. Right, so you realize that in this case, the frequency table is quite interesting because this data here, they give in range. That means for the time between 0 and 4 minutes. So you got to figure out which data point, each data point, which category do they fall under. So for instance, the first data point is 8. Which category does it fall under? 8. 8 minutes. Well, it's under this one, right? So you look at the number 8, right? 8 minutes, and you know that it falls under this second category here. I have 1 tally over here. So you're going to do so for all the data points until you fill up the tally table as well as the frequency table, right? Make sure that total, of course, the total should be 30. If it's not 30, then something is very wrong, right? So find the percentage of students who took more than 9 minutes. More than 9 minutes. Does it include 9 minutes? No, it doesn't. Okay, so X is more than 9, but does not include 9. So probably if we look at the table here, okay, anything more than 9, which categories are more than 9? We're interested in these two categories at the bottom, right? So that's the hint for you. Okay, so after you're done, there's this little section at the bottom for you to think about how confident are you, yeah? So just fill it in. This is for your own learning. I'm not gonna check, of course. Okay. Um, Next, okay, we have seen the bar graph. I think the bar graph is quite neat, but the problem is that it might be a little difficult to read. Okay, so let's take a look. Okay, a group of people were surveyed to find out which brand of chocolate is their favorite. The results are shown in the bar graph below. So on the x-axis over here, we have the y-axis here we have number of people and the brand of chocolate. So there are 5 brands here, A, B, C, D, E. Right. So one note we can tell that brand E is most popular because it has the longest bar in the case, right? But um, you realize the problem, which is that the exact number is not shown. You will have to read off the graph yourself, the bar graph yourself, right? So let's do this together. Okay, let's look at A first. So how do I read this? Well, from the top here, I trace the dots over here. And what is this number? 27. So I'll recommend that when you deal with bar graphs, the first thing that you do is to write down, the frequency, the number, okay, above the bar. So let's finish it together. For brand B, it's 40, 40. For brand C, I'm going to continue drawing the line here. All right, so that's 30, 33. Okay, brand ABCD, D is 40 as well, and E being the most popular, quite clear, is 50. All right, use a ruler to help you. All right, don't be afraid to pull out your ruler to help you. Now, once these numbers are up, I think it's even clearer for us. Okay, we can do calculations based on this. So this is how we read off a bar graph. So which brand of chocolate was the most popular? Clearly, brand E, right? Okay, brand E, we are just asking for the name of the brand, no need to quote any numbers. Which brand was the least popular? Which one? Must be A, right? Because A has the smallest number of lights. So brand A. How many people chose brand B as their favorite? So this is where your work paid in, right? Brand B, 40 people. And how many people chose brand A as their favorite? 27, as you can see over here, very clearly. Now, how many people were surveyed all together? How many? How do I tell from this graph over here? Well, very clear. You just need to add up all the numbers over here. That will tell me how many people were surveyed. Alright, so I'm just gonna quickly do some mental sum. Answer 190. Okay, so total 190. You know what? You can actually write down the presentation. 27 plus 40 plus 33. 27 plus 40 plus 33 plus 40 plus 50. Yeah, that will give you 190. Alright, so yeah, my graph, pretty neat, but you've got to read off. Okay, be careful when you read off. Okay, so this is an example for you to try on your own, right? Follow the way that I do things. Okay, remember, the first thing that you should be doing is writing down all these numbers. Yep. Okay, so another example. Okay, next one is what we call pictograms. Okay, it's the next one, pictograms. Now, to me, pictograms is the worst. It's the cutest, but it's the worst type of way of representing data because it is very, very unclear. One look, you can spot immediately. You spot some problems here. What on earth is this? Is it a printing error or whatnot? Actually, it's not. It is not. This thing represents sort of like half. Is it half a dog, half a cat? Clearly not, right? There can't be half a dog, half a cat, right? So there needs to be a key at the bottom to tell us what each picture means, right? One symbol represents 2 households. So you know that instead of half, this half a dog actually means, one household having a dog, or one household having a cat. Okay, so we should be reading the question first before I dive into the data. So let's do it. The pictogram shows the survey. okay, taken to find the type of pets kept by some household. Yeah? So how many households actually have dogs, have cats, so on and so forth. Right. So each little animal that you see there is represents two households. So immediately, you know what? We can straight away write how many households have dogs. So it's 2 plus 2 plus 1, that gives me 5. Okay. Cats is 2, 4, 6, 8, 9. Rabbits, 4. Others. Of course, others is represented by a turtle, a tortoise. Doesn't mean it's tortoise. Right, 6 of them. Okay. So this column represents number of households. Okay, so you should actively turn pictures into numbers, to have a better understanding of what's going on. So which type of pet is the most popular? Please read the question carefully. Most popular, clearly cats, right? Cat. Okay. Which pet is the least popular? Rabbits, with a frequency of 4. How many households kept dogs, rabbits, and other types of pets? So this is asking for the numbers, no longer the category itself. So dogs, we have done it before, is 5. Rabbits, 4 only, and others, 6. Right, so it's very easy to read off. Yeah. So my question here is, why is it that this chart, this pictogram is not very good? It really depends on the key over here. You see here, the key one symbol, one little animal represents 2 households, right? So for us, it's very clear. Half a dog represents 1. But what if one symbol represents 5? What if one symbol is meant to represent 5 households? How are you going to represent, for instance, 2 households or even 1 household? Right? So one household should be 1/5 of a dog symbol, for example. But how are you going to tell that it's exactly 1/5? Right? 1/5 of a symbol, you'll probably be left with the head, right? Sorry, pardon my drawing. You'll probably be left with the head and maybe a bit of the neck. And that's it, right? That's it. You can't even see the leg. So you won't be able, it's very hard to gauge, is it exactly 1/5, 1/4, or 1/3, so on and so forth. All right. So I think this is the problem with pictograms. All right. Okay, next, how many households were surveyed in all? So all these are very easy. We simply have to add all these guys up. 5 plus 9 plus 4, 5 plus 9 plus 4 plus 6, 24. So 24 households. All right, of course you need not write the units because it's number of households that they're asking for. Okay. Now, see, this is the point where I find it quite weird. Right? Is this exactly half? Or is this, 3/4, 2/3, uh, 2/5, or whatever? It's not very clear, right? But you can always look at a key to give you a hint. Each unit represents 2 fruits. Yeah, so this is probably half. So 1 fruit. Yeah, 1 fruit. Right. So you will do this. Okay, you can pause the video to do this as an example. Okay. Okay, the last one that we're going to discuss for this video, right, is a line graph. Now, line graphs is something that more people are familiar with. Okay, because when we do science, even in secondary school, when we do science and we need to collect data from experiments. Now, this is the kind of graph that we will use. For science, we will not use we'll hardly use bar graphs, hardly. We will definitely not use pictograms, right? Okay. Frequency table we also won't use, right? So all your data will be very likely presented in a line graph. Okay, so let's take a look here. Okay, the graph below shows the monthly income of a manager during the period of 2006 to 2011. So monthly income, let's take a look. So how do we rate this? Well, very simple. Um, For 2006, you just need to dot upwards until you reach the data point over here. Let me zoom in a bit. Until you reach the data point here, then you will read off horizontally. Okay, so for 2006, this is halfway between 3000 and 3005, so it's $3,250. Yeah, so remember that the units is in dollars over here. All right, so for 2006 is 3,250. For 2007 is 3,500. Yeah, so you just dot your way through and you'll get 3,500. So I would suggest that, once you read off the data, you can write it beside 3250. You can write it beside for later reference, right? So for 2008, what am I looking at? This is 4,400. In case you're not sure, take your time to read through. So this is 4,400. Next one, 2009. How many boxes? 1, 2, 3, 4, 5. Yeah, exactly halfway. So this is 4,750. 2010, 5,000. And 2011, lastly, 4,500. Right. So yeah, from this line graph, we can clearly see, without the numbers that we wrote in, what is the trend of his salary, right? It was sort of like increasing, all the way up to highest point here, 2010, before it goes back down to for 2011. So you can see the trend over here, right? But the problem again is you have to read off the exact number for yourself, right? If you look at the commercialized data, the graphs that companies put up for consumers, sometimes they do put the numbers there, right, for easy reference. Yeah. Okay. So what was the manager's monthly salary in the year of 2006? Right, we have already done it. So it's 3250. Don't forget your units, please. 2008, 4,400, 4,400. Right. Okay, in which year was his monthly salary 3,500? So we're asking for the year. Which year was it? 3,500. Yeah, we have the data point over here. Right, 2007. 2007, year 2007, and 4,750. Where were we? This one. Okay, and this is year 2009. Yeah, quite easy so far, just reading off, right, and quoting. Right, so what do you think was the main reason behind the drop in his salary in 2011? What do you think? So this is the kind of question whereby you might be required to be a bit creative, right? So let's take a look of a manager during the period. So for ordinary workers, if you have parents or relatives who are working in sales, you might understand that the amount of salary they bring home every month depends on how much sales they produce, how much goods do they sell, right? So it's a bit like a commission based, right? So yeah, so this could be one reason why is it that his salary is different over the years. If your salary is not based on sales, not based on commission, okay, then in general you expect that over time your salary should increase bit by bit. Depends on your company, right? It should increase over time. But if there's a sudden drop, it's unlikely that it's due to I don't know, maybe the person made a mistake in doing his job, resulting in a salary cut. That is still possible, but quite unlikely. Okay, usually if you make a mistake in your job, then what the company will do is they will freeze your salary. That means next year you won't get your increase. You won't get an increase in pay, right? So a drop in pay could be due to sales, right? That's one possible reason, right? So for this kind of question is what we call free response question, whereby there could be many answers, right? So it depends on whether your answers make sense or not, right? So in this case, I would say it could be due to poor sales. due to poor sales. Sorry. Right, so for that year, 2011, he did not sell as much goods, as he should, or he has been in the past years. Yeah. Okay, so this is the next example. Okay, you can pause the video and try it on your own first. All right, you always remember to write down the value for each data point before you begin. I would say, of course, read the question first, right? It is over a 4 months period. This one is the earnings. That means how much goods they sell of a gift shop, right? So this is when reading the axis matters, right? So for the y-axis, let's see the amount is what is written here is $0.000, right? With an inverted comma, right? $, inverted comma, 000. What does that mean? What does that actually mean? That means all the numbers here that you see on the y-axis, you should actually put 3 zeros behind. Let me show you what does it mean. For September, you see that the amount of sales is actually 2. Now, is it really just $2? Clearly not. It is $2,000. Yeah. So 2, the number 2 here, add on 3 zeros behind. This is what this thing means. All right. So please read your X's carefully. If not, yeah, you might be giving silly answers like the sales is $2. That doesn't quite make sense. All right. So yeah, try it on your own. All right. We will discuss this when we return back to class, return back to school next week. All right. So that's it for this lesson. In the next lesson, we will be looking at the pie chart. Right, we discussed the pie chart. But meanwhile, just try all the examples that I did not go through in detail. I did not show the answer. All right. If you have any questions, feel free to text me, or we can discuss when school reopens. All right. Good luck and take care. I'll see you then.